So today we're ready to unveil one of the most ambitious projects that we've ever undertaken in Superset's history, and we're super excited about it and hope you will get the same level of inspiration here. If you've ever used something like VS Code, has a strong ecosystem of extensions and a solid architecture and dev kit to build these things, you're well aware of the doors that this can open for a project and actually transition it from being not just a project, but turn it into more of a platform that drives both contribution and adoption. So we want to show you how we're approaching this in business intelligence, in open source, and with Apache Superset. As mentioned, I'm Evan Rusackas. I work with Preset, which is a managed commercial version of Apache Superset with some extra bells and whistles and all sorts of fun things. I encourage you to check it out. Michael Molina joins us from Airbnb, and Ville joins us from Apple. All three of us have been PMC members or project management committee members on the Apache Superset project for several years and have been working together on the foundations of this project, and we're widening the net, and we'll tell you how to get involved later in the show. So what we're going to get into is kind of a sampler platter of what this is all about. In case you haven't seen Apache Superset, we'll tell you what that is. We'll tell you about some of the experiences and problems we've been having in maintaining and developing it, and how extensions are the solution to that. We'll give you a couple of demos of how to build these things and try to sell you on the vision and future of where this all leads so you can get involved. So first off, what is Apache Superset? Hopefully many of you have seen it. There have been a lot of talks involving it at the conference so far, which is fantastic to see. And it's an enterprise-grade open source business intelligence tool. We're part of the Apache Software Foundation and one of their largest projects, #1 by GitHub stars as a singular metric. And it's a visualization tool that provides the last mile to your data stack where you can actually gain insights and see what's going on wherever your data comes from. It starts with a SQL IDE that allows you to query pretty much any data source you can think of, either through a direct SQL connection or any other intermediary we do connect to that connects to all the more obscure data sources. And when you write these queries, you build data sets. And those data sets, in turn, can be built into charts via a drag and drop editor where you just bring columns into the various controls of a viz. And those data viz charts and graphs can be turned into dashboards, of course. And dashboards have all sorts of interactivity like drilling and cross-filtering, and you can share them. You can trigger alerts and reports with those. It does a lot of stuff. Everything you'd expect of any BI tool is built in. For the architecture, just very simply, the front end is built of a whole bunch of React components. There's AntD components for our UI. There's Apache eCharts components for our core visualizations. And all of that's built on top of a Python backend served up via Flask and Flask app builder. And it uses SQL Alchemy to connect to data sources through SQL Alchemy dialects, DB engine specs that are part of Superset, and the Python DB API to query data. So Superset really acts as kind of a thin layer to build queries, send them to your data warehouse, pull them back, and visualize them. That's over-trivializing it, but it's really a pretty straightforward stack. So we'll hand it over to Michael, and he can tell us about what this means in terms of where we're at in our development.
Thanks, Evan. So now that Evan has introduced Superset, let's discuss some of the common challenges that we have noticed as maintainers over these years. As the platform's user base has grown, so have the demands from users and organizations for advanced features, custom workflows, and integrations. We have seen requests for new chart types, dashboard components, custom workflows, database connectors, explore controls, AI integration, and more. However, adding these new features to Superset is challenging because of its monolithic code base and the absence of a clear extensibility model. This has led to a situation where many users are unable to add the features they need, and maintainers are struggling to keep up with the demand. Superset currently has a chart plugin system that was introduced as part of SIP6. While the framework introduced a generic chart data API and made it possible to create new chart plugins, the system still required forking the project and modifying files in the core codebase to be able to add new features. In addition, the functionality was largely undocumented, making it difficult to understand by non-core contributors. This led to limited adoption of the plugin framework, and only a handful of individuals and organizations were able to benefit from it. As an additional problem, a significant amount of implementation-specific code has been introduced into the core code base, reducing its reusability and violating design principles. As a result, it has become more challenging to update core functions or improve existing features. We also perceive a need for experimentation in Superset, where developers can try out new types of components without affecting the core code base, allowing new behaviors to be tested and validated by the users. To resolve these problems, we are introducing Superset extensions. Extensions will allow users to extend and customize Superset functionality in a modular and maintainable way without having to modify the core code base. They are defined by a set of proposals, each improving a different part of Superset's architecture. For example, we have a proposal about the vision for the project, one about the documentation portal, one about the core UI components, and one about extensions in Cyclolab. As we update the system and add new features like AI integrations, more proposals will be created. We're starting with Cyclolab because it's a self-contained part of Superset, make it easier to test our ideas and deliver improvements faster. You can find more details about each proposal on GitHub or by scanning these QR codes. Extensions can benefit many parts of Superset. Since our resources are limited, setting clear priorities help us focus on one area at a time and ensures that everyone can participate and benefit from the improvements. Documentation is a key part of the project, along with Cyclolab is one of our top priorities. The next focus area is AI integration. We are currently working on ways for organizations to set up their own models and use the same APIs that extension authors use to interact with Superset. Our future plans include expanding to other Superset modules like dashboard components, chart visualizations, database connectors, security models, and more.
Okay, so now that Michael has established the foundations, a few words about the architecture. So in the old world, all functionality had to exist in the main Superset codebase. That means that to extend Superset, you had to fork the codebase and make changes locally. This made it impossible to use official releases and often required heavy refactoring during upgrades. So in the new architecture, we're introducing 3 new packages. First, a CLI package for building extensions. 2, an NPM package for core front-end dependencies. And 3, a PyPI package for core backend dependencies. The core packages are shared dependencies used by both extensions and the main application. Together, these make it possible to add new functionality to Superset without touching the main codebase at all. So to make this less abstract, we've prepared a few demos to show extensions in action.
Demo will show you how to build a fully functioning Superset extension from scratch in just a few minutes. We'll see how the new framework lets you extend Superset without modifying the core code base. We're going to create a custom Cyclolab view that renders a React component that communicates with the backend. To get started, we'll start our Superset development environment in the VS Code terminal. This is running master branch of Superset, so there's no modifications to the upstream code base. We can see that the backend is now running. And going to the browser, we can see that the application is loading Cyclolab without any modifications. Pay close attention to the bottom pane where we only have the results and the query history panels. So let's jump in. We'll start by scaffolding our extension codebase using the extension CLI tool by calling the init command. We'll call our extension Hello World, and we'll add both a front-end and a back-end component to it. So when the command completes, we now have a folder with our initial extension code. If we go to VS Code, we can now see that we have a backend folder, a front-end folder, and a manifest file with metadata about the extension. The backend folder contains a regular Python project, and the front-end folder contains an NPM project with the typical files, including a Webpack config for building. In the backend folder, we have an entry point file which just contains a simple print statement. Similarly, in the front end, we have an index file that logs to the console during activation and deactivation. To build the extension, we go back to our terminal and run the build command on the CLI. This pulls in dependencies and builds a dist folder that contains the build assets. Once the build completes, we can now expose the extension in our Superset deployment. To do that, we need to first enable a feature flag and then define a local extensions config flag pointing to our extension project. The local extensions config tells Superset to watch the folders for extensions that are under development and to restart the server when there are changes. When we save the changes, we can see Superset restarting, and in the backend log, we can see the print statement from the entry point. And if we go to the browser, we can also see the console log from the activation section. However, if we now make changes to the code, they won't get reflected in our deployment. And that's because Superset only watches the built assets. To fix this, we can start development mode on our extension by calling the dev command on the CLI. When we do this, the extension will automatically rebuild every time there's a change to our source files. So let's see how this works in practice. We'll make a small change to the print statement in the entry point. When we save, the server restarts, and now we can see the new print statement reflecting in the backend logs. So now that we have dev mode running, we can start by adding some real functionality. First, let's add a REST endpoint to the backend. So we'll add a new Python file and define a REST API class in it that exposes the endpoint and returns a random integer between 1 and 1,000,000. Next, we'll register the API endpoint. We do this by importing the REST API module from the Superset core package and then passing the new class to the add extension API method. The new endpoint is now available under the extensions resource, and when we call it, we can see that it's returning a random integer like we expect. Next, let's modify our front-end component. We'll start by registering the placeholder view in SQL Lab. We'll start by creating a new React component called Hello World. This adds a button that calls our new endpoint and renders the result. After we've done that, we add a reference to our component in our activation function. Now when we go to the browser, we can see that the new button shows up, and every time we click it, it makes a new request to the endpoint and prints a new result. Okay, so now we have this working in our development environment, but what we really want to do is actually install it on a production deployment. For that, we go back to our terminal, we terminate dev mode, and we call the bundle command. This generates a new file in the root of the extension folder with the supex extension. So next, we copy it to a folder that the Superset deployment has access to. And finally, we disable the local extensions, and then we set the config flag that tells Superset where to look for extensions. And now when the server restarts, we can see that the extension is now loading the bundle file that we built. And going into the browser, we can see that the extension is loading like before. So with this demonstration, we were able to show the end-to-end flow of creating a new extension, developing it locally, and how to install it in your production environment.
And now that we've gone through the basic mechanics of how to build an extension in Superset, front end and back end functionality to expand the core competencies, we'll do our second demo, which is a more real world example of this in practice.
Hi everyone, I would like to show you one extension that we created to help our users when writing SQL queries. The name of the extensions is Query Insights, and you can see it right here. For this demo, we are mocking all data and code for demonstration purposes. Let's start by running the SQL query here and go to Query Insights. This extension shows relevant metadata information about the executed SQL. For example, the datasets that were referenced in the query, a description explaining the meaning of each dataset, owner information, which is really helpful when debugging problems, a score and certified columns to assess trustworthiness of the datasets. Generally, datasets contain partition fields in their source table, so we also display them here. And the last metadata is a column that displays example queries for each dataset. This is just an example of possible metadata, but you could have way more. This extension has two parts, the back end and the front end. So let's take a look at the code and explain how it works. If you go to the Query Insights extension here, we have the front end folder and back end folder. Going to the extension.json, we can see that this extension is contributing a SQL Lab panel and also a backend entry point here. There are a set of permissions and there are no dependencies yet. So let's go to the dependencies first. If we go to front end and check package.json, we can see that we have some peer dependencies declared here, the most important one being Apache Superset core. Similarly, in the backend, if we go to this file, we can see that we have the Apache Superset core dependency here and an optional development dependency on CLI to generate the bundle files. Looking at the code, the extension is very simple. We have a main file which imports from Apache Superset core and uses its API. So let's take a look at SQL Lab, for example. Here's the whole API of SQL Lab. Maybe look at the outline here, it will be easier to see. Yeah, so we have, for example, some events like on did query run, on did query stop, on did query fail, but also some functions to get state like get current tab. So if we go back to the extension and over here, we can see where it's being used. So the extension is accessing the host API in multiple parts. It's registering a bunch of events like on did query run, on did query success, on did query stop, on did query fail, and acting on each event. What this extension does is pretty much when a query is successfully executed, it will get the executed SQL and call a backend API, passing the SQL and the database ID. Then, with the response, it will build a table, which is right here, a metadata table. The metadata table is simply pure HTML. React and HTML. It's just displaying information. And we have the types defined here. This is the response type. In the backend, if you go to the entry point, we use the REST API function of Superset Core to register a new extension API. We can see this extension here. If we go to Swagger and navigate to the bottom, we will find here a new endpoint under the extensions path related to Query Insights. It's Query Insights / metadata, which is exactly what our front end calls. Going back to the backend, once we register this API, let's go there. It's a simple REST API under the name metadata, and here we are getting parameters like database ID and SQL, which is being passed from the front end. Here, we will normally process database ID and SQL to fetch real metadata. So here we can do multiple things. We can invoke internal services of our orgs to retrieve more information. We could query the metastore, invoke superset commands and DAOs exposed by superset core, or parse in SQL. In this example, we're just mocking the return data because we can't show real code. And what this does is pretty much returning the content that you guys saw in the first screen. This is how the extension invokes the backend metadata endpoint here, which is a new endpoint added by our backend part, and then gets the results, which is here, and display that information in the query insights extension. Thank you.
All right, so now let's talk about what we're going to be working on next. So on the packaging front, we're migrating components from the main application to the new core packages to expose them to extensions. And this also includes the forthcoming LLM and MCP features that have been worked on. We're also working on the release process to automate publishing of these new packages. For the developer tools, we're going to continue improving the CLI and add testing functionality to make it easier for developers to maintain and test their extensions. The aim here is to decouple extension development as much as possible from the main application code base. We also consider development documentation to be a critical part of the extension framework, so we're going to be publishing documentation and tutorials for all features as they're made available. And finally, to minimize duplication, we're going to streamline the main application code base by reusing the new core package APIs internally. And by doing this, we're hoping to dramatically reduce the main code base and make it easier to maintain.
And doubling down on that, minimizing the code base thing, the whole idea here is to kind of shrink the core code base of Superset to the point that it provides more and more interfaces for these extensions as they get developed. There's a lot of refactoring that goes into that, but as these extensions and their interfaces proliferate, we're hoping to see all sorts of new species of extensions being added to the project. So the core project will be smaller and simpler for maintainers, but it'll also be a lot more opening doors for developers to build extensions that let BI do whatever you want, whether it's a number formatter, a new MCP tool, different UI components, adding API endpoints and things that are more bespoke for your business, whatever the case may be. So this will hopefully make Superset kind of the Swiss Army knife for your entire data stack and a very specialized tool for all the things that you do accomplish. And by the time we talk here again next year at the next OSACon, we expect to see a very different Superset that's a lot more capable. The MCP part that was mentioned is a parallel effort, but we have a lot of plans to make sure that the intersection of the extensions effort and the MCP effort are very interoperable. So this will add a lot of capabilities to these extensions as well as these come together. We have a working group you can join too if you want to get involved in that effort. And to that point, the whole mission of Superset for many years now has been to democratize data access and give your entire org and team BI capability and the ability to explore what's in your data. Our new mission is layering on top of that, and it's to democratize BI itself. So anyone can build the tools they need in their BI to better service their business and their workflows. So all of this will be very AI capable. It'll be really quick and easy to develop with these dev tools we've been showing, and it'll provide pretty much any capability you can think of as long as we put all the right interfaces in the right places. So our hope is that this is what really leads to a big turnaround where open source BI kind of takes over the universe. We think we can largely displace a lot of proprietary BI tools by offering all of this flexibility to have whatever visualizations you want, create a marketplace of these extensions, or allow your org to deploy custom things that you've built that make sense for you. So all of this comes together to form a very nice roadmap, and we think it's going to be pretty big. So we encourage you to join us, and to do that, there are several places. We have town halls, and more importantly for this audience, an extensions working group that happen on a regular basis. They're open door meetings. Anyone can join us on Slack to get involved asynchronously, or you can subscribe to the Superset community calendar and come hit us with all your questions and ideas, and we'll help shape this roadmap together and make sure it's everything we want it to be.